Hello students, I'm Jaspreet Kaur and today we are going to start with the new chapter, that is the classification of the elements and the periodicity in their properties. So till now we have just read about the two chapters about the structure of the atoms and the classifications, the very first basic chapter, the basic chemical properties of the elements. Now we are going to study about the chapter which is very important, which forms the basis of the inorganic chemistry, I would say that. In this case, in this particular chapter, we will study that how the different elements, they are arranged in a particular manner in the different periodic tables that were originated, and why there was the need for the origination of the different kind of the periodic tables. Now, first of all, the periodic tables that came into the origination. The very first thing, till late century, scientists, they were able to find out either 30 or 35 elements. In that case, it was very easy, locate which element is resembling the another element, which element is having the properties similar to the another one, and which is having the different properties. But later on, when the scientists, they were really working hard, they were finding out different kind of the elements, it becomes very difficult for them to figure out which element is resembling the another one. And there was a lot of mess that was created, because whenever they have to find out this element belongs to the similar group or the similar category, it was very difficult to pick out that particular element from the group of different elements. So just to figure out this thing, to solve out these problems, there were different kind of the arrangements that were made. The arrangements that were made, it was in the form of a tabular, and in that tabular form the elements were arranged horizontally, vertically, in different ways. Clear? The very first one, that was the Daubigner's triad, where three elements were there taken into consideration, and we were there to figure out which element will be there to follow the next one, which element follow in the similar category. So that was the one way. But till this modern periodic law, it was not formulated, it was not figured out. There was a lot of the problems that were faced in placing the elements together, and then even the elements, they were placed together, they were one or the another kind of the thing, which was found out that this is something which is not resembling with the another element, and how it could be. So to study all these things, we have different kind of the properties that tell us why the one element resembles the another, or if it is different, why it is different from the another element, what is the reason behind the same. So let's start with the modern periodic law. The modern periodic law, I would like to state the statement. First of all, periodicity or the periodic term, it refers to something which is occurring at the regular interval of the time. Clear? For example, our school periods or class periods, in that periods, they are always occurring either after, we could say, the 30 minutes or the 45 minutes. So that is the periodic, means something which is occurring at a regular intervals of the time. Modern periodic law, this was the law which was framed by, or which was suggested by Moseley, who was a physicist, and he was working on the experiment where he wanted to figure out the relationship between the X-ray spectra, the atomic number of the elements. Now what he did, he figured out that there is a target. If there is this target belonging to the set of the elements, this one, it is bombarded with the high energy electrons, then there are the rays, that is the X-rays, which are emitted, and these X-rays, when they are the frequency, it was found out, he figured out that the frequency of the X-rays emitted is equivalent to the A Z minus B, where A and B, these were the constants and different for the different elements. This is the frequency of the X-rays that were emitted, and this was the atomic number of that particular element. Now, till now, what were the scientists doing? They were trying to figure out the relationship between the frequency and the atomic weight, and on the basis of the atomic weight only, these scientists, they were trying to classify the elements in the different kind of the tables, and they were trying to make the arrangements in an orderly manner in a tabular form according to these things only, according to their atomic weights and the the relationship between the other elements. But now what happened, Moseley, he stated out that when I have found the X-rays are emitted by the elements via target which is bombarded with the high energy electrons, and when I draw the graph between this under mu and z, he find out it to be a straight line. That means these are directly proportional to it. From here we get the another thing, that it is the atomic number which is actually responsible for the different kind of the periodicity or the resemblance things that are happening between the elements. So modern periodic law, it states that the physical and the chemical properties of the elements, they are the periodic functions, or they are the functions of their atomic number, not the atomic weight. So that is very, very important, modern periodic law, which refer to the atomic number and not the atomic weight. Now once this law was framed, from there it becomes the basis of the different kind of the things for the understanding and reading out the different properties of the elements. So modern periodic law is the same, that is the physical and the chemical properties of the elements, they are fundamentally responsible to their atomic number. Clear? Moving ahead, we have the modern periodic table that was framed, or we could say that the long form of the periodic table. Now this long form of the periodic table, first of all, it carries the elements in the tabular form, and the elements, they are presented in the order of their increasing atomic number. The elements, they are basically arranged in the order of their increasing atomic number. Now when the elements are arranged in the order of their increasing atomic number, this periodic table, it classifies the elements into the two categories, that is the division of the elements and the periods, the division of the elements in the group. So we have horizontal rows that are said to be the periods, and we have the vertical columns that are said to be groups. So that is very, very important in the long form of the periodic table. If the elements, they were segregated on the basis of the periods, and they were segregated on the basis of the groups. Groups are the vertical columns. Fine, and the periods, they represent the horizontal rows. If I talk about the periods, first of all, already told you, these are the horizontal rows. Secondly, the very important thing, the periods, they represents the main energy shell in which the electron is present. So it tells us about the outermost energy shell or the level. Fine. Later on, if I talk about the periods, in the long form of the periodic table, we got to know that there are the 7 periods in all. Until now, there are the 7 periods only. Moving ahead, it was talked that when the elements, they are arranged in the order of their increasing atomic number, the next period, it will always have the higher number, higher outermost energy shell number. For example, if right now I'm having the shell with the period 1, then it means the next one, it will be having the higher atomic number only, or the higher quantum number as well. Clear? Now studying about the periods, their classifications and how many elements they are present in the periods, that could be easily understand with the table that I'm just going to draw. Please have a look on it. It's very easy to understand all the things about the periods from that particular table only. Okay, so moving ahead, we have, for understanding this concept of the periods in the long form of the periodic table, we have this thing that when we have the n is equal to the 1, the first period when we have the orbitals that are being filled is the 1s, because in the with the quantum number 1, we just have 1s orbital that is available to us. The number of orbitals, the total number of the orbitals, it could be in this particular one, that is the 1. Number of orbital is 1 orbital only, and here the number of elements could be 2. Reason being, in the Pauli's exclusion principle, we have already studied this thing that in a particular orbital we can just accommodate 2 electrons, and if we are accommodating the 2 electrons here, accordingly we can figure it out that we can have the elements that could be filled in that particular orbital in the 2 ways. It means there could be the 2 elements that can be filled in that orbital. Clear? So in the very first period we have just 2 elements. In the second period, when the n is equivalent to the 2, we have the orbitals that are being filled. It is the 2s and the 2p. Now we already know this thing that p, it has the 3 kind of the orientations available with it. It could be 2px, 2py or the 2pz. Clear? So it means here the 3 kind of the orbitals will be available, but with the s there is only 1 orbital that is available. In total we have 1 for this 2s and the 3 for this particular 2p. In the total we have 4 orbitals, fine, and the number of the electrons that could be filled in that 4 orbitals, it is, we have already studied again in the Hund's principle that it could be 1 for the S1 and the 3 for the P, and the 1 orbital it can carry just the 2 electrons. If there could be 2 electrons in the 1 orbital, altogether we can have 8 electrons in these 4 orbitals. Clear? Because we cannot have maximum more than 2 electrons in a 1 orbital. Moving ahead, when the period is 3, it means we have 3s and the 3p orbitals that are subshells that are available to us, and again S, it has only the 1 orbital, it has only 1 orientations, but with the P we have again the 3 kind of the orientations available to us. Total number of the orbitals in the case of 3s and the 3p, it could be 4, and if it is the 4, the number of electrons or the number of elements, it could be 8. Next is related to the 5th orbital, sorry, the 4th one. We have 4s, 3d and the 4p. We studied about it in the Bohrs-Berry rule when we learned this thing that 4s it is filled before the 3d orbital. Again, if I talk about it, if I have the 4s, it means just 1 orbital. If I have the 4p, it means with the p we have the 3 different orientations available, then the 3 orbitals, and if I have d orbital available with me, d, it has the 5 orientations, the possible orientations, and if I talk about the total number of the orbitals that are available, it's 9 in number over here, and 9 orbitals, that means 18 electrons. Moving ahead, the case is similar with the 5th and the 6th orbital. So in the periods, what we found that the number of the elements, they keep on increasing as we move from the one period to the next period. In the very first one we had 2, then 8, again 8, 18, 18 and the 32. Now these numbers, that is the 2, 8, 8, 18, 18 and 32, they were said to be the magic numbers. There is a reason behind calling these numbers as the magic numbers, because the properties of the elements, they are repeated at these regular intervals. For example, the first 2 elements, they might be similar in their properties. Moving ahead, the 8, they will show some similarity in the properties in one way or the another. After that 8th element, there will be a change, and the next 8 elements again with their similarity in their properties. So these numbers, they are considered to be the magic number on the basis of this thing that the properties of the elements, they are similar to each other one way or the another. That was the concept of the periods. We studied about it that there are 7 periods in all, and the different periods with the different number of the elements, and hence their properties also vary accordingly. Next is the division of that particular modern periodic table or the long form of the periodic table into the groups. So when we talk about the groups, we have already discussed this thing that groups, they are vertical columns. Vertical columns that are having the same outer electronic configurations. So I have drawn a table over here of the groups for you people. Let's study about it, that how to read out this particular table and how to know that the elements, they are classified in which particular group and on which basis they are actually classified. So starting from the very first one, fine, we have this S block elements, we call it, and this is the group number 1 and 2. Now group number 1 and 2 and the group number 13 to 17, these consist of the series of the elements in which the electrons, they are either filled in the s orbital or the last electron is filled in the p orbitals. These particular groups which are having the electrons filled in the s and the p orbitals, they are said to be representative groups or the group of the representative elements. Why we are calling it as the representative elements? Because here the electrons, the last electrons, it is being filled in the s and the p orbitals. Fine. So these electrons, they are said to be the s block elements, which are also said to be, this is the group of the mostly reactive metals. Clear? Rare earth elements, they are said to be. Moving ahead to the group 13 to the 18, we have the list of the non-metals as well as the noble gases. So there is a particular, the elements that are present, they are either in the s orbital or they are present in the last shell, that is the p, hence the name is the representative elements. Now as I have already told you people that this is the group of the metals. If I give a look towards this particular group, it consists of the non-metals. Since we find that there is a change from the metals to the non-metals, and in between we have the another groups, we could say that the 10 groups that are present, but they are not belonging to the same category. Since these elements, they are presenting a transition or a change from moving from the metals to the non-metals, they are said to be the transition elements. These transition elements, they have the group which is starting from the 3 to 10. Now why they are called the transition elements? The very first reason is moving from the metals to the non-metals, from the s block elements to the p block elements. Secondly, these are the elements, they are also said to be the d block elements, because here it represents the fourth period, and the fourth period, as we know that it involves the filling up of the d orbital. This particular group, it will be having the elements where there is a filling of the d orbitals. Hence the groups which are from 3 to 10, they will be transition elements, and here the filling of the orbitals that will take place in the d orbital. In the last, we could see that there is a bottom, at the bottom of the table we have the group of the another elements. Clear? Now these groups, there are the two different kind of the groups which are present. The elements which are present in these group, they either start from lanthanum, Z is equal to the 57, they are starting from lanthanum, and the 14 elements which are after that lanthanum, they are said to be lanthanoids. We have the another group of the elements which are starting from the actinum with the atomic number Z is equal to the 89, and all the elements which are falling, all that 14 elements after the actinoids, it is said, actinum, it is said to be the series of the actinoids. Now these elements, these are placed at the end of the periodic table, at the bottom of the periodic table, because they are having the properties which are completely different from these particular group of the elements which are presented on the top of these elements. They are having the properties which are of the radioactive in the nature. These elements, they are also said to be the inner transition elements. Inner transition elements means they belong to the series of the transition, but since it involves the filling of the f orbitals, that is why they belong to the category of the inner transition elements. Moreover, it is having the set of the elements for the belonging to the series of lanthanoids and the actinoids. These are basically very radioactive in the nature. If we talk about the other elements here, they won't be radioactive in the nature. We will never find any element from the S block which is radioactive in the nature. So these are the totally of the different properties, that is why they are said to be the inner transition elements. So here we have learnt about the different kind of the groups. The group first of all which is belonging to the metals, said to be the S block elements. Moving ahead, we have the D block elements, the elements which are belonging to the group with the presenting a transition from the metals to the non-metals. Finally, we had group number 13 to 17 which belong to the non-metals, and this particular group, it is followed by the elements of that is of the noble gases, the elements that belong to the zero group as well. Now the group 13, 17 and this group 1 and 2 in the combination, they are said to be the group of the representative elements, since the elements, they involve the filling up of the s and the p orbitals only. Then moving ahead, we had the inner transition elements, that are the elements which involve the filling up of the f orbitals. They are radioactive in the nature. They contains the series of the 14 elements, one of the lanthanoid series and the another of the actinoid series. So in all, we could see that we have 18 groups. Fine. And in the beginning, as I told you, these 18 groups, if they are similar, if I say that we always call a vertical column as a group, then means the elements which are present over here, the electronic configuration The outermost electronic configuration, in fact, it is same for all the elements, with the involvement of the either one electron in the s orbital or the two electrons in the s orbitals. So they are having the similar kind of the elements with the similar outermost electronic configuration, and it is the outermost electronic configuration only which is responsible for periodicity, because we know that when there is a repetition of the electrons in the outermost shell, in the outermost orbital, then only the repetition and the recurrence of the physical and the chemical properties, not the physical but the chemical properties, it take place. So cause of the periodicity, if we have to talk about it, it could also be said that the outer electronic configuration, because the similar number of the electrons are present outside. It's then if they are having the similar number of the outermost electrons, it would be easy to identify what kind of the properties will be similar to each other. What could be the variation if we are going down, and what could be the variation if we are moving horizontally in a row, that is called a period. So till now we have studied about the periods and the groups, the cause of the periodicity which is responsible for the similarity in the properties of the different elements in the group. One thing I would like to share about it, for example, we say that 1 to 2 these groups over here, the elements that are represented, it could be either NS1 or NS2. That means this belongs to the 1A group and the other one belongs to the 2A group. Moving ahead, if I have the group 13 and the 17, that is the NS2 NP1, that is the 3A group, it could be NS2 NP2, it could be 4th A group, then NS2 NP3, that is the 5th A group, NS2 NP4, that is the 6th group, NS2 NP5, that is the 7th A group, NS2 NP6, that is the 8th A, or we also call it 0 group. Now why I took this till 6? Because we know that there could be only 6 electrons that could be filled in the p orbitals. So that is why we have this particular series till NS2 and NP6. So that was all about groups and the periods. So in this particular video, we have studied about the modern periodic law. We talked about the long form of the periodic table, its division in the form of the periods and the groups, and how the elements, they show the similarity in the properties when they are present in the similar group. In the next video, we will talk about the variation of the properties, their chemical properties, and the occurrence of the periodicity. That was all about this particular section. That's all. Thank you.